So hello, everyone. Thanks for joining us. Today, I will talk about integrating performance management in your development cycle. So, okay, my name is Mark. I work as a CTO at Blackfire.io. So today is a bit special because we meet online. Usually, we at Blackfire try to sponsor a lot of conferences. And we try to have booths at conference, and there is always that sentence that comes a lot. It's from developers, project managers, CTO, CEOs, whatever. We have huge performance issues. So it's obvious why people come to us for that. But it's also always a bit sad because I always imagine these people during their day-to-day job in the deep pit of hell, trying to fight fires constantly. And I think we can do better. And that's why I'm here today, and I will try to propose you a way of having better performance on a day-to-day basis. So first, we have to ask ourselves, what is performance? And the Cambridge Dictionary says that it's how well a person or machine does a piece of work or an activity. It's also the act of doing something such as your job. And I think that technical people like us should take care of performance all the time. We have this man in our industry. It's an old one and funny one. It means that basically you can always disguise a bug as a feature. You can say to people, yeah, no, trust me, it's supposed to work like that. Truth is, for performance, it's not true. You cannot disguise that as a feature. Bad performance is always a bug. So if bad performance is always a bug, we could say that performance is a feature. And as our industry is very prone to invent buzzwords, I invented this one, which is performance as a feature. But I'm not sure I invented this, but I'm using it. And if you want to take another take on this buzzword, you can say that you do performance-driven development. These are funny terms, but the reality behind it is much more important. And we might ask ourselves this question: why do we want performance? What are the qualities behind performance? Why is it such important? And I think that we have three aspects. The first one is the business risk management, even. So bad performance usually means bad business. You have slowness. This slowness brings opportunity costs, like people will drop their cart if you have an e-commerce website. The conversion rate will drop. If you have a software as a service, for example, with a slow website, or your user might churn because your service is too slow to use. You might have higher infrastructure cost as well, depending on your business. So it's fair to say that bad performance costs a lot. There is a lot of horror stories on that on the internet, and some good stories as well about how gaining performance means that you have more users or a better business. So I've selected three stories. First one, the BBC lost an additional 10% of users for every additional second their site took to load, which is brutal, to say the least. Like it's a lot of users. This is the BBC. It's not like a small website. AutoAnything reduced their page load time by 50% and saw a boost of 12 to 13% in sales. So that's a direct correlation between performance and sales. That's great. And at Mobify, for every 100 millisecond decrease in homepage load speed, that resulted in an average annual revenue increase of nearly $400,000 per year. That's a lot of business. That's a lot of money. So performance, money, that means that performance work is not a cost, it's an investment. This investment will bring you more clients or more business. Well, that means that performance work is strategic. It means that you can win customers with good performance. So you can win markets as well with good performance. It's something that we need to keep in mind when we think about the business side. But this is not only about the business side today, it's also about the engineering side. And if you have bad performance, you can say that this is dysfunction of your software. And if it's a dysfunction, then it's a bug. And if it's a bug, then you can treat it as something that should be part of your CI pipeline. You can test your performance the same way you test your features or you do unit tests, for example, which is an interesting thing to grasp. If you work with unit tests in your day-to-day life, you know the feeling it brings to you, like the feeling of stability, of security that you have. It's the same for performance tests. It brings you a feeling of, okay, I didn't introduce any regression in my system. And this is something that makes you feel better in your day-to-day job, which brings me to the third quality of performance to me, which is about humans. Good performance means happier customer, maybe a loyal customer even, and a happier team, I think, as well. It's always a pleasure to work on quality and services that are well engineered and that takes their quality seriously. There is also something that is quite difficult to measure, but that is quite interesting as well. If you have better performance, it might mean that you need less servers. Less servers means less CO2 because it means less energy consumption. And it might also mean less electronic waste. So bear with me here because it's very hard to compute. It's very hard to get figures on that. But we think that there is a link between these topics. Anyway, in order to illustrate what is performance as a feature, I'm going to introduce a character and a classic performance horror story. Okay, so this is Ash versus Evil Bugs. Here we have Ash on our screen. He's not yet to joke, but anyway, his favorite pastime is slashing performance issues on production. Okay, so to do that, he has to do a lot of things. First one, he has to identify a performance issue on production, which is not easy. If the performance issue is on production, it means that a lot of customers has this issue as well. He has to create a fix for this issue. He has to create a pull request. Other people have to review the pull request. The pull request has to be merged. Then it has to be deployed on a test environment, like staging environment, for example. Then the QA validation team can say, okay, it looks good. There is no bug or regression introduced. And finally, the fix is pushed to production. So this is quite a long process, right? But in the end, everybody's happy. Customers are happy. Ash is happy. The team is happy. More business, more money flowing in, and a better system. But now Ash has a new idea. What Ash wants to do is to write a new feature, right? So he says what? He says, okay, I'm going to create this feature. I'm going to spend a lot of time on it. And we are going to through the same process, like creating the feature, implementing it, pushing the code, pull request review, deploying to staging, QA validation, blah, 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 blah. And at the end, yes, you have your feature deployed to production. But unfortunately, as Ash didn't have performance as a feature implemented in his development cycle, he introduced a performance regression. And you can see the cycle repeating here. So his first work was wasted. So the lessons of this story is that the cost of this scenario is awfully high. We have someone fixing something in production and then running his work by implementing a new feature. It's the same as when you don't have unit tests or functional tests. You can introduce the same type of regression. So here, you can have a framework that can help you with that, which is good, right? And you can, with performance as a feature, you can detect this regression before it hits production. So you can bypass all the QA validation and all that stuff. You can test it on your own computer, so that the cost of working on performance is quite low actually. But there is always a lot of people, and of course nobody has unlimited money, and they will say, yeah, but we don't have the budget for performance. But if you think about it a bit, you will say, okay, but it's the same as saying we don't have the budget for test, which is at some point is saying money is so cheap that we love to burn it. And from the ash of burning this money, what we find is technical debt. It's always the same kind of scenario. So if you want to work on performance, you have to measure, but you have to measure what? You have to measure what matters. The first thing you can measure is the wall time. What is wall time? Wall time is you have a clock on the wall, and the request comes in your HTTP application. You look at the clock on the wall, the response goes out, and you look at the wall again. You make a difference of the two measurement of time, and you get the wall time of your request. You can measure as well the memory consumption, or the number of SQL requests you made, or the number of HTTP calls you made during this time. You can also measure the size of the HTTP response, because you want your response to be lean, as lean as possible. Or maybe you have a big microservice in your infrastructure that is really, really slow to call, and you want to time the number of you want to measure the number of time this service is called. So once you measure what matters, you want to measure it everywhere on your call machine, so that when you are a developer and you develop, you can have real-time analysis of the performance. You want it on your staging environment as well, because you don't want the regression to happen on production. And you want also to be able to understand what happens in production in case you have these very rare things that only happen in production. That happens all the time, right? And there is only one tool that can give you that much information on all these environments, and this tool is a profiler. The profiler, it's, as Wikipedia says, a form of dynamic program analysis. You might know static program analysis, but here it's dynamic. It means that it runs while your code runs. And this profiler it's a big measurer. It will measure the space, the time complexity of your program, like for how long it ran, how much CPU it took. It can say, okay, this function has been called that much time, which is super interesting, right? It can say, yeah, this function consumes that much memory. So that's a lot of deep data and very interesting data for a developer. So right now at Blackfire, we are focused on profiling, and we are focused on profiling for PHP because this is our historical tool, programming language. But we are also introducing support for new languages such as Python and Go. Today, we are going to focus only on PHP. So how do we work with PHP? We have what we call a PHP extension, which will hook into the PHP engine. And with that extension, we can see everything that happened in the PHP engine box. We can see every function call, we can have timers for every function calls, or we can have the network input or output of every function. When we have all this data, then we post-process it. We anonymize some stuff like the SQL queries. We will prune some part of your profile that is not relevant to you. Like only we remove all the non-statistically significant calls, and we do that without any overhead on your system. There is no overhead because we do that on demand. You're always in control of when you want to profile and what you want to profile. Once you have this data, you can have a visualization. For example, this is the call graph visualization. And you can see where the time has been spent. You can see the number of times a function has been called. For example, here the run method has called 20 times the wait method, which has called itself the read pipes method 60 times. And you can see that for the whole execution of your profile. But you can get more, actually. You can get also metrics, measurements for example, the number of Elasticsearch queries you made, the number of emails you sent with your controller, or the number of times this template in Symfony was called. You can basically have measurements for whatever you want. And if we don't provide you like enough metrics, you can create your own one because you know what is expensive in your own application. And you can create measurements specifically for that. But that's not all. You can also automate these measurements. And this is what we call scenarios. You can write scenarios saying, okay, I want to go to my own page, and on my own page, I want to be sure that I don't have more than 5 SQL requests. This is the kind of scenarios that you can make. We will see later, but you can also create much more complex scenarios, such as login scenarios or add this item to the cart scenarios. And you can see the performance of every step of these scenarios. So enough with the theory. Now let's go with the practical side of things. And we're going to implement performance as a feature in SymfonyCloud with Blackfire. So we will need first a few things, right? We will need first the Symfony CLI. If you are a Symfony user and you haven't used the Symfony CLI yet, well, do yourself a treat and try it. It's very good. Then you will need as well the Blackfire CLI. This is a small command line tool to help you interact easily with Blackfire. And I will use as well, everything will happen in the terminal. And I will show you some other tools. You might not know them. The first one is GQ, which is a JSON processor. You can use it to query some fields in a JSON document, for example. And Hub, which is a command line tool to interact with GitHub, for example, for creating pull requests and that sort of stuff. So the first step is to create a Symfony project. And it's pretty great to use the Symfony CLI for that because they give you a demo project that you can instantiate with that command. Symfony new --demo talk-demo. Talk-demo will be the directory that contains the Symfony application. Then you will go in that directory and you will bootstrap the Blackfire.yaml file, which contains your assertions, your metrics definitions, and your scenarios. Everything that you need to have performance as a feature implemented in your project. So once you have run this command, you will have a new file in your directory. This new file is .blackfire.yaml. And this file has 2 sections. The first one is the test section. Here we define a test that is named the homepage should be fast. We all want that, a fast homepage. This test will only execute on the homepage, which is here the slash symbol, the first, the slash URL. And this test contains one assertion, and this assertion is, I want my hold time to be inferior to 200 milliseconds. Why 200 milliseconds? It's what Google recommends, basically. That's why. The second section of the Blackfire.yml file is the scenarios. And here we define a very simple scenarios that say, okay, when I go to my homepage, I want my status code to be 200. If you know functional tests, you can see that here it's a pure functional test. The big difference is that when this when the test is executed and that it goes to the homepage, the test as well, the test on the metric will be executed. So we will ensure that your hold time is inferior to 200 milliseconds. And here you have functional tests and performance tests at the same place, which is pretty great. Okay, so we have our project. We have our first test, and now we need to deploy that to SymfonyCloud, right? So what you do, you type this command. It will ask you some questions. It's very quick to answer. And it will generate a lot of files in your directory. One of the main important files is the .symfony.cloud.yml file. This file contains the configuration of your application. So here, we need to modify this file and say, okay, please add Blackfire to the list of PHP extensions available on my application. So I've shortened the file a bit for this slide, otherwise it's a bit bigger than that. You can modify, of course, a lot of different things, but here this is only what is of importance for us. Okay, so now our project is set up. So we can commit everything and we can deploy. We can do our first deploy. If you haven't already do a deploy on Symfony, this is what it looks like. I've sped up things a bit so that it's not boring, but it's basically that. And it is deployed. Then you need to configure Blackfire on the server. So you go to the Blackfire website, you get your credentials, and you can type this command. Then you redeploy your application so that the environment variables are taken into account by the PHP process. And you're set up. You have your application online with Blackfire and ready to be used at any time. But there is one thing missing. And this thing is that when you deploy, your future deploy, you want Blackfire to run tests on these deploys. Like if you write a new feature and you deploy this feature, you want Blackfire to run all the scenarios. Like, okay, I want my page to be quick. Is it quick? Yes, no. So this is what we call adding integration. And you can find this URL in the Blackfire documentation, for example. All right, so we can do our first profile here. And you use Blackfire curl for that. So Blackfire curl is just a curl wrapper that will inject some specific stuff of Blackfire to the request. It will trigger a profile on your application. It will trigger 10 profiles. And we will aggregate all these profiles. And in the output, you can see that there is one successful test. This successful test is your front page test. Okay, and yeah, the hold time was 32 milliseconds, so it's way inferior to 200 milliseconds, and that's a success. You might want some machine readable stuff in your in your day-to-day environment. For example, if you want to have a custom CI script, so you can say, okay, run this profile and use GQ to report the state of the test. So this is, you get easily the state of the test in the terminal. But you can also have the web UI. And the web UI will give you all the assertions here. So here we have 32 milliseconds. It's way inferior to 200. We are green, which is cool. So the test feature is very important in your day-to-day life when you're developing with Blackfire. And you can have a lot of tests. For example, you can say, okay, I want my wait time to be inferior to 200 milliseconds. I also want my peak memory usage to always be low, very, very low. And you can say on all my pages, I want my peak memory usage to be inferior to 40 megabytes. A quick example for Blackfire, for example, we have specific tests on our application, and we want to make sure that some request takes less than 4 megabytes of memory. You can also say, I don't want my number of SQL requests to be too high on my admin page, otherwise it's too slow. You can make that test on your admin page, but you can also make that test on all the pages you want. And we have also features that say, okay, I want my, like when Blackfire does a test, I want the next test to have a difference of metrics count that is inferior to 5. So if I have five SQL requests on that page, and at the next test I have 11, then there is a problem, and I want to be alerted of that. You can create your own metrics as well. So you can say, okay, I have this service that is really, really slow to run. This Markdown processor is very slow to run. I don't want to have it on the home page. So here I will define a rule that says every time this is called, you will increment this counter by 1, and you will create a test saying, okay, I want this counter to always be equal to 0 when I'm on the home page. That way, you are sure that this service is never called in critical situation, for example. So back to scenarios. On scenarios, you can create complex scenarios like, okay, I want to try my login page. You can go to your login page, you can fill a form, you can use variable to fill this form, you can follow redirection, expect status code to be a certain number. You can say, okay, I want my page to be this one. Like if you're used to functional tests, this is basically the same. And the difference that at each step, you will get a profile, and then you will have your performance tests that are run on this profile. So it's nice. You have every tools that you want to have tests for your application, but there is still one thing missing. And this thing is that you will create a feature, you will deploy a new environment, you will create a pull request, you will commit, you will deploy, and all that stuff. But if you use GitHub Daily or GitLab, you know that commit status are very important. And that is something we support as well. You will have commit status for your pull request. For example, here, I introduced something that trigger a wrong test, and my page became slower from one test to another. So my commit status is red. I know that I introduced a performance regression, and I can work on fixing this issue somehow. So this is all that you need for having performance as a feature implemented in your development cycle. In normal time, I said, okay, I want you to go home with these key takeaways, but I guess you're already home. So please remember that performance is strategic. It's not a cost, it's an investment. It will bring you a return on your investment. And also that in order to have a meaningful performance work, you need to integrate that in your daily development cycle, okay? You will reduce the probability of performance regression. You will reduce the cost of performance work as well, which is pretty amazing because it means that for a lower investment, you will get a higher return. And you will help your developers making better decisions faster. So thank you. And if you have any questions, I can answer them.